Hello, hello everyone. My name is Opetubo Oriyomi. I'm a master's student at the University of Johannesburg, Mechanical Engineering Department, and I will be doing a micro talk on absorption, hydrogen diffusion through vanadium nickel zirconium composite membrane surface for hydrogen purification through the first principle method. Introduction. Hydrogen is an alternative fuel to replace fossil fuel because it is a renewable energy and it is environmental friendly. It can be extracted primarily by splitting water molecule, hydrogen reform gas, or gasification of coal. In order to utilize the hydrogen generated, high purity of hydrogen is required. Hence, it must be separated from impurity like nitrogen, carbon dioxide, carbon monoxide, and methane, etc. Membrane separation is the most promising purification techniques used in separation of hydrogen from impurity. Palladium is the most common used materials in metal membrane for the separation, but due to its scarcity, scientists all over the world are looking for an alternative, and it has been discovered that vanadium is can replace palladium because it is very cheaper and has a higher diffusivity than palladium. Problem description and material model. In this figure, we could see the pink represents the hydrogen, the white atoms represent nickel, while the green represents zirconium, and the red represent vanadium. We used Vesta to develop the model, and we use VAPS, which is implemented in CHPC through the CHPC to perform the simulation, and we got our output. From the diagram, we can also see that in the first diagram, the hydrogen is introduced to the surface of the membrane. Then, after the simulation, in the second diagram, we see the hydrogen is permitted through the membrane to the subsurface of the membrane. Result and conclusion. Table 1 shows the lattice constant and the solution energy. After performing the simulation, we discovered that the lattice constants of the membrane changes from 5.452 to 6.036 with hydrogen and without hydrogen, as shown in the table. The volume also increases as a result of hydrogen, which expand the lattice parameters of the membrane from 489.391 to 728.76. Also, the density of the membrane was calculated to be 2.545 grams per centimeter square. The solution energy was also calculated using the equation 1 in above. We calculate the solution energy with 0 point energy and without 0 point energy, which is presented in the table. We further study the diffusion coefficient of it using the Arrhenius equation as shown in the equation below under the figure. We plotted the graphs as shown in the second diagram, which shows that the hydrogen diffusion through the membrane is far better than the one that has been reported in the literature. In conclusion, the diffusion coefficient rate of the at the operating temperature of 623 Kelvin is determined to be 0.699 times 10 raised to power minus 4 centimeter square per second was determined, which is far better than other vanadium ternary alloy. The effect of the hydrogen in the lattice parameter was also determined, and the reference are listed below. Thank you all.